Okay, we go to our this topic, artificial neural network. Right? Okay. First of all, we must to know what is linear and non-linear. Okay. Yesterday we already covered about the linear regression. So, what is the difference about linear and non-linear relationship? Okay. The graph below give three examples: positive linear, negative linear, and non-linear relationship. Non-linear means there is no straight line in this graph. Okay.
Dr. Saiful,
Yeah.
sorry for disturbing. I think that is for okay. Now I can see the slide because it's remain at the first slide only previously.
Okay.
Okay,
Oh,
now it's okay.
maybe slow.
Uh,
Alright. Right. Okay. So you can see the graph already.
yes, already. It's
Alright.
okay.
So this is for the example of the we want to compare what is positive linear, negative linear, and non-linear relationship. Uh, so when we talk about linear, it must be a straight line in our graph. So this is our data, our tabulation of data, and then this is a non-linear relationship because the graph will be not a straight line but a curved line. So what is so different with these two? Okay, linear, you can see here. Okay, semua nampak yang ni
Nampak.
Oh, nampak. Alright. Okay, so okay, linear ni. Okay, regression each layer from neural network. Same with the artificial neural network because it's we go from the dependent variable and we go to the regression and we come up with the model. We want to know why. So the structure of a perception can be visualized as this one. So this is a picture about what is happened in the linear regression. Right. So okay, you can see here an equation that has constant rate of change.
Dr. Saiful, we don't see the equation.
Equation.
It's stuck at this slide number 3. In my screen, what I saw is only slide number 3.
Right. See what happened. So this
This one, slide number 4. Okay, we just saw this one. Now
okay.
is slide number
I,
5.
I think I cannot go to the slideshow lah. So we go
Okay.
see one by one like this lah.
Okay.
Alright. Okay. Okay, so semua boleh faham kat sini Okay, linear. As shown in the graph like this, but when we visualize as a structure of perception, it became like this. Alright. So what is about a linear regression? An equation that has a constant rate of change. Constant rate. There is no single rule to memorize about what make an equation linear. Instead, focus on looking at a lot of example. Okay, kita nak tahu. We want to know the what we call the function make a straight line when it graph. So if your data give good in a goodness of fit R square like we talked yesterday. So benda tu tak perlu kita risau lah sebab dia tak perlu kita data tu memang orang kata apa menerangkan dalam bentuk yang dalam straight line, dalam linear. But if the data cannot describe in the straight line, so we can go to the non-linear punya step lah. Okay, confusing kan sikit Okay, tak apa. Okay, ni this is the example for the linear. It must be straight line, can go up or down, and the steepness of the line is called slope. Okay. In multiple integration, it must be this one, the straight line. So, if our data, the our tabulation of data is scattered everywhere, so it's hard to get this straight line. Okay, so if our data is go apa is have a very good relationship between x and y, supposed to be we can get this linear line, right? All right, so we go to the non-linear. Okay, non-linear, it will become like this. Dia macam ular sikit je ni. It have a curve ups and down. So the structure of perception can be visualized like this one. We have several output, several input. We go to the what you call it, perception of this apa, the kita masuk dalam independent variable, and then we go to the hidden nodes. I will explain later what is hidden node, and we'll come up with the output. So when we make neural network, we can get most possible, and at least we can get more better model rather than we use the linear regression, because the line is following the tabulation of the data. But of course, it depends on our data lah. If our data has no relationship at all between x and y, so it's almost possible to get the good or to high R square. Okay, ANN perform well, generally better with larger number of hidden nodes. More hidden unit will generally produce lower error. Okay, this one I will cover later. What is hidden unit? What is a larger number? Because in ANN, we use hidden nodes. Hidden node, this one, to mimic or to try to get the best way to fit the data. Okay. Okay. So far, faham tak the perbezaan antara non-linear dengan linear? Ataupun saya terlalu laju kat sini?
Okay, faham. How about any
Yeah.
others?
Macam mana? Kalau tak, saya boleh ulang balik, ataupun sebab kita nak nampak the the picture of what is the difference between non-linear and linear. So mungkin ada yang macam confused sikit kat sini. Apa itu hidden, apa ini saya akan explain kemudian. But I want to emphasize that linear must be a straight line. Even though your data is no correlation, but or good have a good correlation, but if you cannot get a correlation between this x and y, you cannot get the straight line in the linear. So there is no relation between x and y. But in non-linear, it will calculate or it will compute as much as the computer uh, can go with your data, as long as there is correlation between x and y. But if don't the x and y no correlation, it hard to get the good R square. Okay, but it still can apa nama, dia boleh akan pergi juga macam mana yang sebaik mungkin lah, sebab dia dalam bentuk yang bukan straight line, dia akan ikut data kita yang kita nak. Okay, ni secara laymannya macam tu lah. So for the difference between linear and non-linear. Okay. So
Dr. Saiful, can we say that if we found our result doesn't have R to the R square is low,
Yeah.
maybe less than 0.5, is it possible that we just try to use ANN to find the nonlinear correlation, something like that? Is it that the
Yes.
only
Ah,
option?
yeah. Dr. Shirwan. Okay.
Hmm.
If our data we use MLR, we get below than 0.5. So, uh, you can apply ANN to make to get the more apa to get the high R squared rather than
Hmm.
you just using MLR, because in ANN they have several hidden nodes here. So you can if okay, after this I can explain about hidden nodes. So in ANN we can use one hidden node, two hidden node, three hidden nodes, and we also can use more than 10 hidden nodes
Hmm.
until we get the best R squared we want. All right. But the problem is the formulation will be too long, or too it's very lengthy, then it's not so applicable for our research lah. Okay. So, dia akan
Okay.
keluar dalam bentuk coding kat sini. Jadi kalau if you guys is familiar with coding, so is not difficult for you to understand. But the objective, if we want to make it less hidden nodes and um, much accurate the accuracy of the model. Okay, but that I can explain later. So it just our mukadimah lah kat sini, apa perbezaan antara linear and non-linear. Okay. Okay, in non-linear, this could be almost an equation that does have a constant rate of change. Okay. Okay, this one any question that does not create straight line when graph is non-linear function. Okay. Selagi mana dia tak ada straight line, kita akan kata itu ada non-linear function lah. Kita guna non-linear function lah. Alright. Okay, non-linear give the best goodness of fifth and better R squared can be used as predictive model. That's this one. Okay. Like I stated before, if our data cannot get the best R square to make a model, we can apply the ANN method to get the better R square. So it will go we apa akan mengikut taburan data kita lah kat sini. Okay. Itu objektif kita menggunakan ANN. That's our main objective, to use the ANN. Okay, so far I hope you understand the difference between linear and non-linear. So we can go to the ANN part and what it is NNN. So ANN come from a neural network. Neural network is actually is similarity with biological network. We use our brain. So how brain give signal to our nerve to move, to work, to whatever our body wants to bergerak atau berinteraksi. That is neural network. So fundamental of processing element of neural network is a neuron. Receives input from other source, combine them in some way, and perform a generally non-linear operation on the result, output the final result. So maksudnya ANN ni dia more kepada computer science. Dia apa nama dia meniru perbuatan otak kita lah. So maksudnya dia tak diikut macam straightforward arahan, dia akan cuba untuk memberi arahan seperti mana yang sebanyak mana faktor yang boleh dibuat. Okay, itu secara dalam bahasa Melayu. Macam itulah maksudnya ANN is mimicking our brain. So that is the beauty of ANN. Okay, one type of network sees the nodes as artificial neuron. Okay, what I said about hidden node. Node is like artificial neurons. So when we use the NN, we will go with the nodes. Nodes will come with better result because it's mimicking the neuron, our apa nama brain punya neurons lah. So it consists of pool of simple processing unit which communicate by sending signal to each other. Alright. So upper to NN is a random or deterministic model which can allow prediction of the complication of the variable. So if you guys have more complicated data or more is very large data, so ANN is the best way to make a predictive model. Because when we use MLR, it's just a very straightforward punya technique. So if there is no relationship between X and Y, so we cannot use the MLR. So it will we cannot use the MLR and the model is not significant. We apply lah because we give us the uh, apa orang kata R square yang tidak bagus. Okay, kat sini. Okay, nampak AN ni dia akan mimik kita punya dia akan macam kita punya pemikiran, dia akan pergi selekuk mana yang boleh untuk mencapai tujuan iaitu output kita lah. Itu kenapa saya menerangkan melalui non-linear and linear kat situ. Alright. Okay, rasa ada yang tak nampak lagi ni, tak boleh teruskan. So, ANN can compute any computational function. Okay, as long as a selection of network topology and weight value. Okay, dia ada trial and error kat sini. Alright. This is the comparison between biological neuron and artificial neuron. Alright. So boleh nampak kat sini you can see here. This is what we call it. Okay, rasanya ada yang lebih pakar kat sini. Okay, ni yang dekat otak lah ni. Okay, this is like our brain and give the neuron to make the arahan lah kepada anggota kita lah. So it's same with the artificial neuron. Wait, okay, this is our interconnection, and then the process kat sini, and then it gives our output. Alright, the imitation of human neuron. Alright. So how do NS work? Okay, this is more like our input, our independent variables, and we go into this summation unit, and then we transfer for the outputs lah. Okay, ini pun sama. Okay, ada processing dia. Okay, so if you guys want to use ANN, you must describe what is ANN in your study or in your article or in your thesis like this, because if you want to explain what the neural network is about, input, processing and output. That's the basic of ANN lah. Okay, same. Okay, hidden layer. Okay, how many hidden layer is up to us lah to identify or to choose. As long as we get the best output as possible lah. Right? So, okay, learning by trial and error. Okay, when we talk about prediction, we must have a trial and we must evaluate and we must adjust, because any model, not just prediction model or any environmental model, we need to have where we need to evaluate between our model is good enough to use in a real situation, because kadang kita punya data kita nampak bagus dalam result, tapi bila kita guna in the real life, kita punya result tu tak seperti apa yang model tu tunjukkan. So we must have this trial and error lah to get the best model yang kita perlukan lah. Alright. Okay, so kat sini faham ke tak? Nampak gambaran tak kat sini? Do you guys have any question about this graph before we continue? Atau saya terlalu cepat ke, ataupun saya explain terlalu putus ke? Boleh saya dapat feedback tak kat sini? Sebab saya takut nanti kita
Okey je
buat nanti
rasa.
tak faham. Boleh
Saya rasa
Alright.
nanti bila dah buat example nanti dia akan nampak lebih clear.
Okay, good. Sebab teori ni macam saya cakap, saya bukan mathematician, saya bukan orang computer science, tapi saya dah apply lama benda ni dan saya dah berguru juga secara non formal, but this is the way lah. This is the way we talk about ANN. So tak apa, nanti kita apply, nanti saya rasa insyaAllah semua akan faham lah. Okay, so we continue. Okay, ini pun saya rasa boleh baca nanti saya akan share PowerPoint ni dalam folder. Okay, how to design, we need the initial way, okay, transfer function, okay, kita ada error estimation, okay, kita ada adjusting weight kita, how many number of neuron, okay. So error estimation, okay, this one is very crucial in ANN. The root mean square error. So we must see two value lah in our result. First is R square, and then the second one is RMSE, root mean square error. So a smaller RMSE value is good our model lah. Lagi mana nilai jumlah value RMSE dalam result kita nanti kita akan tengok. So lagi bagus kita punya model tu, sebab the error dah makin kurang. Alright, so RMSE R square is important to put in our result lah after we produce our model. So okay, root mean square error. Alright, okay, weight adjusting. Okay, after each iteration, weight should be adjusted, minimize the error. So dia ada back propagation, and kita tengok all possible weight lah kat sini. Okay, what is back propagation? Okay, in NN we have usually we use feed forward ANN lah. Feed forward means we go just from X to hidden node and comes to output Y. So backpropagation ni is an example of supervised learning to minimize the error between the layer, and so the error of each hidden layer is an average of the evaluated error. So dia ada teknik backpropagation ni, dia akan minimalkan error yang berlaku. Okay, ni pun kita akan cover nanti. Okay, this one I think not important. Okay, number of neuron. Okay, remember if we get many neuron, high accuracy, but it will make it slower and risk of overfitting. Sebab the network will be useless with new problem. Okay, dia memang akan memberi kita accuracy lebih baik. Just like I said, the more hidden nodes, the more accurate, but it will more very length of our formula and make it slower lah. But if few neurons, if we go to zero or one hidden node, it will give lower accuracy and inability to learn at all. Macam otak kita macam kalau kita ada banyak banyak kata possible to factor to try to get the best Y lah. Kalau kurang kita punya factor tu untuk kita gunakan, maksudnya dia akan lebih kurang accurate kita punya data lah. Alright. Okay, size of training set. Okay, you boleh baca sini. Overfitting can occur if a good training set is not chosen. Okay. The size of training set is related to the number of hidden neuron. Okay. Kalau banyak hidden neuron itulah the size of training set kita nanti. Oh, nak habis dah. Okay. Summary. Provide a way of learning features. Okay. ANN ni. And highly nonlinear prediction function. Okay. Also, highly parallel network of logistic regression classifier. Okay, logistic regression, we will not discuss this topic because we focus on MLR and ANN. Logistic is another technique lah. Okay. So, discover useful hidden representation of the input. Okay. Okay, kat sini kita nak tahu apa perbezaan dia antara NN, kita nak tahu apa itu hidden units. Okay, what is hidden units? Kenapa kita hidden units? Macam saya cerita, dia mimik pada neuron. So, bila ada more hidden unit, kita akan produce lower error kita, lower RMSE. So, our model can be useful to our real situation. Okay, real problem, we can use the model. And then kita will choose single learning rate. Choosing single learning rate is possible. Okay, difficult to reduce training time, altering network topology or learning parameters. So terms yang jargon-jargon dalam ni is more into the computer science lah. But at least you have a picture about why and what is ANN about. Because we want to apply after this. Okay, everyone. So, you guys already open the exercise?
Yes.
Alright. Okay. So, I believe all of you already installed the JMP. So, okay, we should continue. So first, how to convert the Excel worksheet to JMP. Okay, make sure the exercise river 03 you save in you save as Excel 97 to 2003 workbook. Okay, before we convert. Okay, let me show. Ada keluar tak? Oh,
Belum lagi.
Okay, sorry. Okay, before we convert, first of all, we must save our file to from Excel workbook.xlsx to Excel 97 to 2003 workbook. Okay? Get?
Okay.
Alright. Okay, then you save your folder. So, okay, then you open the JMP. Okay, and then you open the Excel new Excel worksheet, which is exercise river 3.xls, and then open. Okay, semua dapat macam ni tak? It will come with the Excel import wizard box.
Doctor, can you repeat again?
Alright, okay. Okay, at a JMP home window, first you must open the Excel, which is exercise river 03 dot XLS 37 2003 punya format lah. Alright. Then we open the Excel to the JMP. So it will pop up the Excel import wizard box. Okay. Semua dapat ke?
Sekejap doktor, kejap.
Okay, silakan. Okay.
Dr. Saiful, saya punya dia appear Excel import wizard window. Tapi benda tu tak sama macam Dr. Saiful punya.
Yes, correct. Because my JMP is JMP 13 version. So you guys may be the latest one.
Okay.
Okay, Dr. Amal. It did not come out. Okay. Are you already converted into Excel 97 2003?
Yeah, done, doctor. But I have the recent file window only open, and then there is a window list, but I don't get the window like yours.
Okay, because my version is JMP 13. Maybe it's not very same with the latest version, but it's possible to use.
So
Right? Yeah.
how do I import? Doctor, maybe import multiple files or how?
Okay, wait. I explain.
Okay.
Alright. So
Fine.
okay. How about the others? Dr. Azli, Syarul, Daya. Okay. Okay. So at this worksheet, okay, I think maybe it's a little bit different with yours, but the function is very same, I think. Okay, first in this one, you select the sheet one, the original data, because yesterday we come up with a very several sheet after we using MLR, but I want you to choose sheet one, the original data. Alright? Nampak tak kat sini? You guys get at the worksheet?
Dr. Saiful, we don't see any your sheet 1 in your presentation.
Tak keluar lah. Wait. Wait eh. I see. So no pop up here.
Perhaps you can choose show your screen.
Okay. Okay. You guys see the import and set import wizard?
Yes, this one.
Okay, alhamdulillah. Okay, so I know your Excel must have several sheet because yesterday we come up with result from MLR, but at this one, you choose sheet 1. Sheet 1 for the original data. Alright? Okay? Dapat tak? Pilih sheet 1 yang daripada original data yang pertama. So dia takkan keluar semua uh, semua yang lain-lain lah, yang result yang MLR semalam lah. Alright? So if you guys already select the sheet 1 and then you guys click import. So it will pop up a new box for the sheet 1. So it's already converted into the JMP from your Excel. Okay?
Okay.
Okay, semua dapat? You guys get this one?
Dr. Amal didn't get the Excel wizard yet.
Okay. How? Dr. Amal, can you share your screen so we can rectify the problem?
Okay, 1 second. Is it coming? Is it coming, Doctor?
Yeah, we can see here.
Okay.
Okay, first you go to the open folder, yes.
This one, right?
Yeah, the file picture icon. And then you choose the exercise river 03. In Excel. So we want to know how to import first.
Okay. So the one we converted just now, right?
Yes.
Okay.
Alright, open. That one.
Okay.
Okay. And then
So sheet 1, yeah?
sheet 1, yes, import.
Import.
Yes.
Okay, thank you.
Alhamdulillah. Okay, good. So we continue.
Yeah, I will stop sharing, yeah?
Alright. Okay. Alright, guys. Okay, so you get this box with this new window, which is our converted Excel into our JMP. So we can see here we have a point A and point B, and then we got our variable parameters here and WQI. So how can we use this one into the ANN? Because yesterday we already learned about how to make a prediction model using MLR to predict water quality index. But how can we use the same ways but using ANN? Okay, first of all, you guys go to Analyze tab. Okay, Analyze tab, and then you go to the predictive modeling. All right, and then you guys click the neural. Okay, I repeat again. First of all, you guys go to Analyze, and then you go to predictive modeling, and then you guys click neural. So what is so special about JMP? Okay, before we go to the analysis, so this one have several analysis, same like SS stat, but JMP is under SAS software. SAS is a very well-known software about data analysis, statistical analysis, but mostly SAS using coding. But this one is more user-friendly because we just click and we can get the result just what we want lah. Okay, you can explore this software later, but first of all, you want to know how to make an ANN first. Alright, so you guys go to analyze tab and then choose predictive modeling and then you guys click neural. Okay, okay, get semua dapat tak kat sini?
Dapat.
Kata kita dah laju. Alright, okay, alhamdulillah. So okay, this box give us several apa nama box lah dalam box ni. Okay, dia ada select columns, they have a cast selected column into rows and get action. So first, at the cast selected column into rows, in Y respond, you guys click WQI as our Y. So click WQI and then you guys click Y respond. So it will drag this into this column. Alright. And then for the X factor, you guys put all the variable or all the parameters as a dependent variable. So we chose BO, BOD, COD, SS, pH, American nitrogen. Okay. Okay. Semua okay kat sini? You guys okay? Boleh follow
Yes.
Alright. So then we just click OK. So you guys can see the neural box. Okay. So here we get hidden nodes. Okay. Just like I said from the PowerPoint, it's more hidden nodes and more accurate the model. But the cons is if we give more hidden nodes, our model will be will be length and terlalu panjang kat sini, too length and it's so difficult to calculate again. So first we just try one by one. First we go with one hidden nodes, right? For validation method, you just ignore, and reproducibility we just ignore. Okay, you just change the hidden nodes to one. Okay, and then you go. So this is our first result. So we got R square is 0.95 and validation is 0.98. Why we have training and validation? Because when we use the ANN, we need a training phase and then the computer will calculate for validation. So if our training is high for R square but validation is low, that's mean our model is not very suitable to use in a real life situation, real life data. So ayat layman ni macam tu lah. So okay, if you guys want to add more hidden nodes, you guys click at the model launch and then you guys make it two hidden nodes. You can see the difference between R square for one hidden nodes and two hidden nodes. So when we go to two hidden nodes, we get more higher of R square here, 0.97 and 0.96. Okay. Okay, saya repeat. I repeat again. First of all, you guys make predictive modeling, neural, and then put WQI as Y respond, and then you select all the other parameters for the X variable, the X factor, and then click OK. Okay, you guys will get the neural box. Don't change anything, just change the hidden nodes. Okay, start with hidden nodes 1. Okay, and then go. So you get the R square here. But you guys will get a not same R square every time you redo the analysis, because it's about a neural. It's not fixed like MLR. So once you get 0.95, the next you redo the analysis, you can get a different value. That's different between ANN and MLR, because it just following they compute the non-linear punya analysis lah. So maybe it's very between us lah. So if I get 0.96, you guys maybe get 0.95. So it's okay, as long as we get the value here, because it's neural, not fixed itu same value. Okay, semua dapat kat sini?
Yes, Doctor.
Alright, Alhamdulillah. Okay, so if we are not satisfied with this R square, we can click at the model launch, and then we go to hidden nodes 2. Okay, is get higher R square and get slower RMSE. So this is our aim here. Must be training and validation, at least have a high for validation and high for training. So we can go as many as you want for hidden nodes. You go to 4 or you go to 5. Okay, we try 5. Okay, 5 also get constant value, almost the same with 2. So we just use 2 hidden nodes here for better model. Alright. Okay, do you get from here?
Yes, Doctor.
All right. Okay. Good. Okay. So how can we translate this model into our result? Okay. This one, you can copy column or copy table into our for what call it, boleh copy table ni ke dalam Words untuk kita buat kita punya result lah. We can copy this column into Microsoft Word, so we can use as our writing lah. Alright, so how can we see the difference? So first you click at the red arrow here, and then there's several like chassis diagram, show estimate, profiler, content profiler, and so on. So first we click at the plot actual by predicted. So here we can see here the actual by predicted plot. So this one predicted against the actual WQI. So we can see once we get the best R square, we can use this one as a training and validation of plot. Okay, so it's good. And then how can we know the formulation for our formula? You guys just click the red arrow here, and then you guys choose make SAS data step. So it will come a new box in a coding. So this is our model.
Dr. Saiful, Dr. Amar request, can you repeat?
Okay, boleh. Okay, we go back. Okay, so here we go for the saya ulang balik lah senang saya tutup dulu. Alright.
Oh,
So
first one, okay, doctor. The second part, the SAS data.
okay, wait. I make it. Okay, go for the notes. Alright. Okay. Okay, this one. First, you guys already get the R square, and then you want to know the actual by predicted plot. Okay, we get the training and validation, and how can we know the our formulation model. First, we go at the red arrow and then click make SAS data step. Okay, make SAS data step, and then you guys will see the SAS window here, and then this one is your from hidden layer code until response mapping code. This is your formulation. Okay, then you copy this one into Microsoft Word, right? So benda ni leceh sikit lah. It's very um, many step to to see. Alright. So here our model. So how can we use this model into our data? First, we go back to our data. Our Excel. Okay, so we make a new column WQIANN, and then we copy. So this is one hidden layer. So make sure you guys make H1 here before we go. H1, which means hidden layer 1, because we choose only one hidden layer. All right. So you guys put all together from tan to close bracket here, and then you guys put it in the function box like this. Okay, so this one you must make sure your formulation is correct. So like this one, DOMG, you just select this one into DO, VOD, into this one, okay, COD, okay, SS, VH, okay, ammonic nitrogen, okay, and then you try function. Okay, this one is your H1 value. So how to get the WQI? You go back to your copy word, theta 1 equals to 97.96 blah 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 times with H1 plus 67.26. So WQI predicted equals to theta 1. So this is the WQI model for ANN, and then you just copy this one into your Excel, and then you guys just change the number here with H1, and then you click. Okay, so this is your WQI, predicted WQI using ANN. Okay, am I too fast here?
Sorry, Doctor, boleh repeat tak?
Perlu saya ulang balik kat dia ni? Boleh. Okay, so kita buang balik. Okay, first you guys from the SAS window. Okay, awak semua boleh nampak dalam ni ada coding ya. Dalam ni ada coding. So from the coding ini adalah kita punya formula. All of this is our formulation for our model. So because we use just one hidden node, so it's only one H1. If we use 4 hidden nodes, so we will get H1, H2, H3. So it will more lebih panjang lah dia punya coding lah. Okay, so first of all, you guys just copy this one into Microsoft Word, so you guys will not confuse. Alright, you can see here hidden layer code H1 theta 1 equals to WI predicted. So we got this. Oh, sorry. So we go back to our Excel sheet. So exercise river, and then we make a new column here, H1. If you guys use 4 hidden nodes, so you will make 4 column for H1, H2, H3, H4. But for this one, we just only use one hidden node, so we got only one column for H1 lah. Alright. So how to calculate H1? We copy all of this formula, and then we put in the function box, and then we paste. Then the next step, we must check our formula. So if our formula is wrong, or we have changed ada sengkang ke, we have a backspace here, we must betulkan dulu. Alright, so first we select the DO, and then we click at the value of DO at the row 2, and then same with BOD, same with COD, also as DH, and amortization and project. And then so if we guys get the problem, which mean our function, yep, bila kita dapat macam ni, maksudnya function kita ni tak betul lah, kita ada jarak kat sini. So kita kena check betul-betul balik. Okay.
Doctor, sorry, the error means that we have spacing, yeah?
Yeah, we have spacing. So
okay.
Double check our function here.
Doctor, I think the error is because ada semicolon at the end of.
Oh, yeah. Okay. Okay. Thank you.
Okay.
Semicolon. All right. Thank you.
Welcome.
So if we have spacing or any semicolon, we can continue to our formula lah. So this one Okay, thank you. Okay, then for the predicted WQI, we WQI using A and N, and then for this formulation, we use the theta 1 here, because this is our final formula lah for our prediction. And then we go back and we copy this, right? So we make sure there is no space, and then we copy back this one with H1. So yeah, we get back to the final result of our prediction of ANN. Alright. So okay tak semua? Ada tak yang lost kat sini? Ada error ke apa? Okay. If you guys have error, make sure there is no spacing between the formula. and then you guys check uh, apa nama the formula lah, betul atau tak lah kat sini. Alright, so this is we do for manual. Macam mana kita nak tengok manual? Alright, boleh tak kat sini?
Boleh.
Alright, alhamdulillah. Okay, so kita explore lagi Okay, this one, how you want to use the hidden note. Alright. Okay. So actually this one you can copy. You can copy graph and put in Microsoft Word. So how to copy? Just right click at the graph and then you guys click edit and then copy graph. So you can use this into your writing for journal or thesis, copy graph and then just put at the Microsoft Word. Okay, this one for training and this one for validation. Okay.
Dr. Saiful, how many data that they use for validation? Is it they automatically do it or we need to state somewhere?
No, it automatic do. It already calculate for us. So this one, dia terus automatic dia akan kira untuk validation punya ni.
Okay.
Okay, so kat sini apa lagi kita boleh tengok Okay. That's all for the easiest exercise. So guys, macam mana? Ada soalan tak kat sini sebelum kita pergi exercise lebih mencabar? Do you guys have any question here?
Macam yang doktor mention tadi,
Ya.
dekat ANN ni kita boleh tengok dia punya error kan yang RMSC. So kat mana je kita boleh tengok?
Ya. Okay, dekat sini you boleh tengok kat sini error ni. RMS ni 0.8 bawah R square ni. 0.6.
Oh, sebab dekat saya punya dia tulis RASE.
RASE. Tak ada RMSC, tak ada
Dekat saya tak ada.
Betul-betul. Saya pun dapat RASE. Baru perasan.
RASE.
So adakah RASE itu sama dengan RMSE?
Nanti saya tengok balik, saya double check balik sebab tu version baru jadi saya tak pasti. Tapi biasanya memang RMSE lah. Kita kata root mean square error. RA. Saya tak pasti itu. Okay, tak apa.
Alright, okay, tak apa.
So, Dr. Shirwan, saya rasa yang validation part ni we can see at the sum frequency ni 26. The JFP already choose how much of data they want to use for validation.
Maksud dia as if dia memang dah 50% lah dia choose.
Ya.
Yeah, because some paper kalau kita baca dia request 60-40. Maksud dia 60 training, 40 tu validation. Macam tu lah. And then some of it kita boleh pilih.
So validation ni I think maybe the berkenaan dengan validation yang kita boleh pilih fallback ataupun K-fold. So benda tu memang biasanya kalau pengalaman yang saya pernah buat, saya guna fallback sajalah untuk for validation sebab itu dah sesuai untuk penggunaannya. Okay. So okay, that's all for exercise 1. I think you guys can we go for the comparison go back. So for this one, I think there is not so many different if you want to compare between WQI for AMLR and WQI for ANN, because these two models give almost very much similar with the actual data. So if you guys use the other data, maybe the MLR give you 0.2, so you guys can use the ANN for better R square, and then you can compare the from using MLR and from using ANN. So okay, so this is for the exercise 1. So can we proceed with exercise 2, or we want to take a short break so you can try explore before we go? Okay, I forgot to mention from previous exercise. Okay, wait. You also can make diagram. So for more understanding in your writing, all right. So you go to the red arrow here, and then you click diagram. So below we can see this is our diagram for using one unhidden node to get the output WQI. So if let's say we use 3 hidden nodes, so the green circle have they have 3 hidden node here. So okay, let's do for 3 hidden node. So we go to 3 hidden nodes. So for better understanding, you can see at the diagram, just like our slide. When we have 3 hidden nodes, so this is the diagram. So for more understanding lah. Okay. So this one we can copy. Right, sorry. Edit, and then we copy picture and we put in our Microsoft Word. So if you want to explain about NN in your articles or your thesis, this one is very visualized. Okay, so it's up how many hidden nodes we want to put. If we get 5 hidden nodes, so we will get 5 green circle here. Okay.
Dr. Saiful,
Yes.
again, how did we plot the diagram just now?
Okay. How to copy?
No. How to get the diagram just now?
Okay. First, you go at the red arrow here.
Huh?
Then you click diagram.
Diagram. There is no. Okay, the first one. Okay.
Yeah, the first one. Yeah,
Okay.
diagram. So you can get the what you call the flow of the ANN.
Okay.
How from the input, so you go to the hidden nodes, and then you get the output here. So this
Okay.
one
Got it.
will can help you to better understanding lah what is happen in the end process. All right. So just like we mentioned, RMSE, root mean square error, and RASE is root average square error. Mean and average is on the same. So assume this is the same. All right. Okay. So we finish our first exercise, and then I want you to make ANN for the second exercise from exercise A 0.7. Okay. Okay, I give 10 minutes. Okay, yes saya.
Boleh saya nak minta tolong dengan equation tu tak?
Okay, ada masalah ya?
Sebab saya tak boleh nak kira calculation tu. Bila macam nak gantikan contohnya FE tu dengan value tu tak boleh.
Okay, saya tunjuk cara Alright, jap. Ataupun boleh share screen ke? Kita
Boleh.
tengok sama-sama. Alright.
Ini dia the equation tu kan. Dia nampak ke?
Sorry, saya off mic lah. Okay, dekat sebelah tan tu saya rasa macam tak ada sama dengan. Betul tak? Okay, tak sama dengan dulu. Okay, so select yang FE tu, iron tu. Ya, boleh tak?
Tadi.
Alright,
Dia
so make sure tak ada space tak ada sengkang di antara tambah dengan negatif ataupun tolak tu. So kena dapat. Alright. Okay, so I share entire window. Entire shit. Oh, sorry. Stop sharing. So from the API, we use 3 hidden nodes. Okay, so I want get on the same quickly. H1, H2, H3. We have 3 hidden nodes. So and the final layer code to predict API. Alright. So if you can see here, for me, I got R square 0.999, and for validation also I have 0.99. So it's good for prediction model by using 3 hidden nodes. So this is my diagram. So how I macam mana saya keluarkan diagram ni. Okay, just click at the diagram and then you see here the diagram and the actual predicted plot. We got here. We are almost at the straight line because we got 0.99. Ada tak siapa-siapa kat sini dapat selain pada 0.99 dengan 3 hidden nodes? Ataupun semua dapat yang sama?
Sama doktor, sama.
Sama
Same, doctor.
Same. Okay, alright, same. So for the Excel sheet, okay, we got H1, H2, H3, and then we come up with the final answer. Right. So before we compare, can you use MLR to make a model for API, and then we can compare actual API MLR and API ANN. Okay, then we can compare it.
All right.
What R square you guys get from the MLR? I got 0.98. Is it same?
Yes, doctor.
Alright. Okay, so when we use ANN, we got 0.99 and MLR 0.98. So almost same, but when we comparing with the and actual API using predicted by NN and MLR, and then we come up with the line chart, we can see a little bit different between the actual by NN and MLR. Okay, kat sini kita dapat tengok perbezaan yang ketara MLR berbanding dengan API dengan ANN. Nampak tak kat sini? Okay, there is a error between MLR and the actual. But if you can see the blue line and the orange line, almost the same. So that's the difference between we using ANN and MLR. So ANN give more accuracy rather than when we using MLR. So this the first case, but kita dapat tengok perbezaan tu hampir tak ketara sangat, not so many different, because the R square from these two technique give high of R square. But when we got MLR lower than 0.5, it will get more fluctuate of different between the actual and the predicted by MR. But if we use ANN, more hidden nodes, so maybe it can get almost similar with the actual. Okay, so this is the difference between ANN and MLR. So after this, when you use the MLR and ANN to your data, you can see the difference. Okay, but as I mentioned before, if your MLR is good, so that tak perlu guna ANN pun tak apalah. You don't use ANN pun is okay, because your MLR is already good. But if your MLR is give low of R square, then you can choose to use, you can decide to use for NN technique lah. Alright. So okay, any question about this before I want to show you the fastest and the easiest way to get the value? Ada soalan tak? Sebelum saya tunjukkan cara yang lebih mudah untuk kita dapatkan value tanpa kita kira satu-satu.
Tak ada soalan.
Alright, okay. So, okay. We go back to JMP. Okay. So how can we get the predicted value without we calculate from the formula to the Excel, but just using JMP? Okay. Go back to the box here, and then you click at the red arrow, and then you all click save formula. Okay, I repeat. First, you go to the model, the red arrow, and then you go to save formula. Alright, and you go to your worksheet. So here, the already calculated H1, H2, and H3, and the predicted API. So why I show you how to calculate? Because I want you to know the importance of the formula. Because after this, what is your prediction model? You must show the formulation, not just the result here. But if you want to you already know, you already understand the formula, and then you can use this method to get all the value you want without you calculate into the Excel. Okay? Dapat tak kat sini? Maksudnya ni cara lebih mudah lah. Jadi saya hang kat sini lah. Alright. So sini kita boleh copy saja. Copy. And then kita patah balik ke kita punya Excel and then kita just paste. So dah dapat lah balik apa yang kita dapat tadi. Kan? Sama kan? So tak payah susah lah nak kira kat sini. Jadi maknanya cara yang lebih mudah lah. Alright. So dapat nampak kat sini
Alright.
Okay, good. Okay, before we have one more exercise. Okay. Kalau ada yang nak share data ataupun kita nak buat sama-sama, boleh dipersilakan drop dalam folder inbox. So kita boleh cuba sama-sama. But before we go to the final exercise, ada soalan tak kat sini?
Tak ada.
Senang kan? Alright, senang je ni. Very easy because it's user friendly. But first, I want to make sure you know how to come out the coding here, the formulation here, and then you can compare it with the actual one. So when you got the best R square, so you can apply to your own data lah for prediction model. Okay. So we go to the next exercise. Okay. Can you open exercise rainfall? Okay, semua dah buka ke? Already open the access rainfall. Saya dah share dalam.
Okay.
Alright. So, okay, when you see this this sheet, so this is the rainfall for.
Mr. Saiful, you don't share.
Oh yeah, sorry. Alright. Aduh, ya. Okay. Alright. So this is the data for rainfall. We have a station and day. Day we have about 254 days from 11 station. 12 station. So how can we predict rainfall level between this tabulation of data. So sebagai contoh sini kita dah differentiate level antara low, moderate dengan high. So this one rainfall level we already make three classes. Three class, low rainfall level, moderate rainfall level and high rainfall level. Okay. So how can we predict rainfall level just using the tabulation of data? So this one we create kita yang buat je sendiri, not from the jabatan jabatan sungai ke apa? Apa dah
Geology.
Ya, sorry.
Geological department.
Yes. So they just gave only rainfall, not rainfall level. So this one we must identify how the rainfall level. So I already make it rainfall level, but how can we predict rainfall level just using ANN? Okay. First, we go to analyze, and then we make a predictive model, and then neural. Alright. So we see here rainfall level. Okay, rainfall level. We go to the response, and then the day 1 until day 254, we go to the X factor. Alright. So this one, we come up with one hidden nodes first, and then we go. So yeah, we get 0.999. They gave us confusion matrix. So when we see the confusion matrix, the group of high, low, moderate gave us 100% correct here. 111. Correct. So this one you can see how can we calculate the level from such window. So here the formulation, and then we can see also how it calculate our formula here. Most likely RF level, low, moderate, high. Okay, so not just using numbers, but we also can use classes or not bukan nombor ataupun level macam ni untuk kita jadikan sebagai Y. Okay, we can use not just a numbers but the classes for our prediction using ANN. But for MLR, we cannot use this one. So ANN, we can use this function. So we can predict, we can make a model. So if you guys are using like Syahrul using pokok orchid data, or the Azlin use air quality. So the air quality have a what we call it, the classes for air quality. So we can use this also for our model. Okay, nampak tak? Jelas tak kat sini? Maksudnya walaupun bukan nombor, tapi kita boleh modelkan kita punya variable kita dalam bentuk macam ni, dalam bentuk kataan dan kelas yang di sini menggunakan ANN. So ni specialnya dengan ANN. Okay? Ada soalan tak kat sini? Atau nak saya ulang balik ke macam mana? Dapat?
Doktor tolong ulang.
Okey. Alright, saya buka balik. Saya takut tak nampak. Alright, wait. Alright, so first we go to exercise rainfall. Okay, so this one is different. Different from the previous exercise. So this one is tabulation of rainfall data from 12 station. We got almost 254 days of rainfall from 12 station. Okay, so biasanya usually the Jabatan Berparitan Berparitan ke betul ke? So state lupa. Okay, dia akan bagi kita they give us only the rainfall, not the level. So the level we must find using multivariate analysis, so we can class the rainfall level. So the problem is how can we predict the rainfall level using ANN? Okay, because from MMR we cannot calculate the rainfall level because this is not a number. Ini adalah kelas dalam bentuk perkataan. Kita tak boleh kira dengan MLR. Alright, so how we using ANN to predict the rainfall level? First, we go step by step, just like previous exercise. We go to the numeral, and then rainfall level as our Y, and then day 1 until day 254 as our X. Okay, so we okay, and we just use one hidden note here. Okay, so we got 0.999, so almost 1 R square. So when we using confusion metric, okay, you guys familiar tak dengan confusion metric, confusion rate apa semua? Atau ini first time dengar? Is it your first time see the familiar, right? Alright, okay. So if you're familiar with multivariate data, so you know the confusion matrix when you are using discriminant analysis. You can see the confusion matrix. So how good the grouping jatuh kat mana. Alright, so this one we can see the confusion matrix is very good. So you give 1 here and then predicted also, and then how to come up the formulation, we just follow like the previous step. We can see the formulation. Okay, so bila kita nak gunakan ni dalam penulisan kita, kita just boleh gunakan lah. Kita mungkin boleh simplify sikit dia punya decimal places. And then we use the response mapping code lah. Okay, but for the presentation we use the formulas here. So the JMP will template for us, and then this is our final most likely RF level, low, moderate, low, high. Okay, dia tak cakap RF level prediction, dia kata most likely because this one is not in a numbers. So dia akan bermain dengan probability kat sini. So ini yang menariknya dengan ANN dengan menggunakan JMP, because not just a value or numbers, but we can use the non-numerical punya data. So if you guys have a small, high punya class ataupun value ataupun apa-apa sajalah yang bukan non-numerical, you can use it as a prediction. Okay, boleh dapat kat sini ataupun masih blur kat sini.
Doktor, dapat. Cumanya kalau dalam dalam Excel stat we have DA, right? What is the
Yeah.
difference?
Sebab kita nak predict kat sini. Kita nak predict dalam masa sama dia dah menjawab dengan DA lah. DA dia tak kalau tak salah dia tak ada untuk prediction. Tapi ini kita boleh gunakan formulation tu untuk buat prediction. Yang DA kita nak kelaskan dia, nak dalam nak differentiate dia punya kelas dia. Adakah kelas yang kita tentukan tu betul-betul dalam kelas yang sebetulnya. Tapi bukan functionnya untuk kita buat prediction. But dengan ANN kita boleh gunakan konsep yang sama dalam kelas, tapi kita boleh buat predict kelas tu. Menjawab ke? Atau Dr. Syirwan pakar dengan DA ni. Mungkin ada penambahan kat situ.
Dr. Syirwan sila tambah.
I think dalam the difference is kalau if we see that if we run the same data with DA, usually they don't produce any we call them functions yang that formulation lah, how to predict the low, high and medium through DA. But when we use this ANN, actually this is the first time that I know that this ANN able to do the prediction qualitatively. So and then they can produce a formulation as if actually this ANN is similar what PLSDA, partial least square discriminant analysis can produce. They can predict qualitatively, but they together can produce a formulation on how to predict lah. The what you call that one? The difference is different algorithm being used between that PLSDA and this ANN lah. Yeah. So for us, I think if we want to compare, we just compare to the RMSE between both of these functions or multivariate tools, and then we can choose which one is the best lah. So this is what I found today because previously I never knew that the CNN able to predict like the DA and PLSR can do. Okay.
Alhamdulillah, thank you Dr. Syirwan for this explain about the DA, LSDA. Yeah. So I think there is new something new also. You know that ANN not just a quantitative data, but quantitative data also we can use as a prediction, as a Y. So that's the beauty of ANN lah. So it's very like mimicking our human brain. So not just the numbers, because MLR just only using quantitative. If we use the non-numerical punya data, dia tak boleh kira. It cannot compute the result. But in ANN, they use probability to come out the prediction for the non-numerical punya data. So that's my point lah for the rainfall data. Alright. So okay, so this is we finished our main exercise. I think I can find one more example, one more exercise for you. I want to show you what if we use three input to find 5 output. Alright, so ini saya akan tunjukkan saja. I want to just to show you how to how to get the apa nama the using ANN. But if you guys have data or you guys have your kita cuba sama-sama lah data anda semua, kalau boleh kita buat kot kita dapat come out dengan satu solusi lah untuk ANN. So okay, Dr. Shivan, can we have take a short break because I want to find one more example to show.
Okay, we come back at 12.
Okay, boleh nampak Okay, this one is air quality data at Federal Port of Malaysia. We have several port here from Johor to Sarawak. Okay, the problem is, can we predict the number of container or number of ships or number of ton of ships using these parameters? Okay, so we convert it to JMP. Okay, and then we use container ship and ship GRT as our output or Y dependent variable. Okay. Okay, then we got the air quality parameters. Then we go to model launch here. Right. So we can see here the model gives 3 models in container, model for ships, model for ships GRT by using air quality parameters. Okay, so is that possible? We predict just using air quality. Okay, for if we use one hidden node here, we can see R square is very low, 0.1, 0.2, and 0.2 for GRT. So how can we use this as our prediction model? So of course, if we have low R square, which means our model is not good. So the difference between actual and predicted will be nampak lebih jelas perbezaannya. Okay, so we can launch more than one hidden node. Let's say we use 15 hidden nodes. Okay, when we use 15, we get at least high of R square here, 0.7 for container. Ship we got 0.6, and then ship GRT we got 0.6. Okay. What if we use more than 15 hidden nodes? Okay, we try again. We try 18. So when we use 18, we get the value is lower than we use 15 hidden node. So which means here the maximum of the more what we call it, the ideal of hidden nodes, we can use at least just 15 hidden nodes. So we select 15 hidden nodes for our model, regression model. Okay, jelas tak kat sini maksudnya? Maksudnya kat sini, jika kita gunakan satu hidden node, kita dapat nilai yang R square yang rendah, kita tambahkan kita punya hidden nodes kita daripada 1 kepada 2 kepada 3 kepada 4 sampailah ke paling ideal hidden nodes. Bila dah lebih pada hidden nodes tu, bila kita tambah lagi hidden nodes, nilai R square tu makin rendah. So maksudnya dia dah sampai ke tahap yang maksimum kat situ, optimum kat situ. So kita pilih yang paling optimum. Okay. When we use more hidden nodes, but if we got the already optimum, just we use the optimum one for our prediction model. That's our objective here. So for this one, when we can see at the diagram, so this one is our diagram. From air quality as our input, we want to predict how many container, how many sheet for GRT at the federal ports in Malaysia. Okay, just using ANN. Alright. So okay, when we use the formula, we can see. Alright. So this is our. We can see here we have so many hidden nodes. 15 hidden nodes. 1, 2, 3, 4, 5 until 15. And then we got the predicted for container, we got the predicted for ship, we got the predicted for ship GRT. Okay. Nampak okay, kita boleh cuba copy ke semua ni. And then kita compare dengan actual punya data. Okay, so why in black dot here? Because from our actual data at the CO, we have a missing data. So the computer cannot calculate the prediction, so it gives no value at our predicted value. Okay, so then we want to compare all together the actual. Okay, let's see. Okay. So this model is not very good because we got R square is 0.7.
Doctor
Yeah.
Saiful, you are missing the ANN data because you copy paste the original data to the ANN data.
Oh, I see.
Because your intention want to copy the title.
Yeah. Alright. Thank you.
Okay.
Saya tak perasan. Sekejap Alright. Okay. Go back to our original data. Ya, betul. Laptop saya ni hang sikit sebenarnya. Alright. Okay. Nasib baik. Saya kena copy satu-satu. can see the prediction is teruk sikit lah sebab ada negatif kat sini. Jadi tak bagus. Ni pun saya gabungkan, combine from Department of Statistics dengan Department of Environment data lah. Alright, so you can see the difference from our nampak, you can see prediction is not good because our R square is lower than 0.7, I think, because the training phase. We can see the training 0.4 validation, validation negative. So even though your training is 0.8, but if your validation give the lower R square, it will give the what we call it bias, or tu tak sama dengan actual R square kat sini. So walaupun 0.7 ataupun 0.8, tapi kita punya training validation kita rendah, maksudnya data kita tu bermasalah lah. Hampir semua, tapi banyak yang berbeza lah. We have a very different kat sini. Okay.
Adakah ia disebabkan oleh missing values, Doktor?
Maybe. Ya. Sebab kita ada missing value, boleh jadi antara faktor lah. Okay, ni untuk sheet. Ini untuk sheet. But bila kita gunakan data kita yang kata almost impossible to predict ataupun tu, tapi kita masih boleh gunakan juga, orang kata, sebagai membantu sikit sebanyak data kita dalam prediction. Kita tak akan dapat 100% tepat sebab ini bukannya magic ataupun bukannya ahli nujum lah kan, kita nak dapat tepat. Tapi bila taburan data kita tu banyak dan bagus, insyaAllah macam kita gunakan exercise sebelum ni, kita dapat hampir tepat dia punya ketepatan prediction tu. So yang ni ada masalah sebab satu, kita ada missing data, satu lagi sebab dua kumpulan yang berbeza. Satu air quality, satu lagi bilangan kapal. So mungkin dia akan memberi sedikit perbezaan kat situ. Okay, Dr. Ahmad, what just I said, if you have very different type of data, just like in this one for total of sheep against air quality, but we want to know, can we predict the total of sheep just using air quality at the same area? So this one, I just make a prediction model to show you it is possible, but it has a very not so good in the prediction lah. But for better accuracy, maybe we must add more parameters, or we must have very good very large pool of data lah, data set. So when we have a large pool of data set, maybe the accuracy will be less, will be more, and the error will be less. Okay. Point yang saya nak cerita kat sini lah. Okay, kita boleh buat, tapi kadang-kadang data kita tu tak seperti yang kita harapkan lah. Sebab not all our data can show the best prediction value. Alright, but if this one, if you want to make a journal or model, you just say this is the way we can predict. Not same, but memuaskan lah. It is acceptable lah for prediction. But we must see the value of R square, we must see the value of RASE, and we must see the difference between training and validation. If too far different from training and validation, So it will give us not so good or not good in our prediction lah. Okay, we can see here at the predicted plot. Okay, when we use a training, all the data we can see the tabulation of the data nearer to the straight line. But when we use the validation, you can see it's a bit far from the straight line. So that's why we cannot get the best of our data prediction. Okay, so this is 15 nodes. So if you guys have your origin data, but if using just 3 nodes, don't give a good R square, you just add more and more hidden nodes until you get the best or the best optimum of R square. Let's say if 15, you get 0.7 or 0.8 or 0.9, and then you go to 16 hidden node, you get 0.4 or 0.3. So you just choose 15 hidden nodes. Don't continue because it will never get better R square. Okay. So ada soalan tak? Any question about this situation, this problem? So saya cuba gabungkan beberapa situasi kaedah. Tak semestinya kita nak predict untuk satu jalan. Kita boleh predict banyak possible, banyak variable. Contoh kat sini kita ada kontena, kita ada kapal, kita ada kapal dalam jumlah berat. Jadi macam mana kita nak buat prediction? How can we predict this variable by just using equality? Okay, this is the technique lah. But of course, not all can we get the best of model, because first we have a missing data. The second one, the fluctuation, the variation of data is too large, so we cannot get the best model yang kita mahukan lah, yang just like we want lah. Okay, so if you guys have a very large pool of data, try to treat and clean the data first, eliminate all the outliers, eliminate all the unnecessary or abnormalities in your data, and then go for the prediction. Inshallah, you can get the best model you want. Okay, you must try and error lah for from using the ANN. Okay. Alright, so this one. Okay, ada soalan ke? Any question?
Saya ada soalan, tapi dia more to application lah. So macam Dr. Saiful dalam industri kan?
Ya, betul.
Okay, boleh saya tahu tak selalunya kalau dalam industri dia selalunya dia akan report apa ya? Adakah dia akan report R square dan RMSC ke macam mana?
Dari segi statistik okay, kalau industri yang real punya industri lah, saya tak tahulah, biasanya dia akan tengok orang tak tekankan sangat tentang statistik, dia tengok suka-suka tengok frekuensi je sebenarnya. Ni yang realitinya lah. Tapi kita dalam academician, dalam bidang akademik, kita kena terangkan dalam bentuk statistik. Kenapa? Okey, kita boleh tekan dari frekuensi, kita boleh, ni saya general lah, saya jawab secara general. Kita boleh jawab dalam frekuensi, tapi dari sisi statistikalnya belum tentu itu menjawab frekuensi kita. So untuk soalan tadi, saya rasa kita macam Dr. Hidayah
Tak, Hidayah saja.
Hidayah. Okey, sekarang buat apa? Postgraduate ataupun
Saya researcher. Tapi more to industry skill lah.
Oh, industri. So tak ada masalah bagi saya, tak ada masalah. Macam Cik Hidayah pun mungkin dah ada familiar dengan report apa semua kan. Jadi saya rasa perlu juga untuk masukkan elemen statistik dalam report kita, sebab itu kalau lebih mengukuhkan kita punya report lah ataupun kita punya penulisan lah. Sebab bila kita dah belajar benda ni, at least kita sesuatu yang lebih lah. Itu pendapat saya, itu menurut saya, pendapat peribadi saya lah. Mungkin Cik Hidayah ada pandangan yang lain ke, saya tak pasti.
Okey, tapi yang Dr. Saiful kata yang frequency tu maksudnya yang predicted value maksudnya.
No. Ni yang tadi saya jawab secara general. Maksudnya
Okay.
saya tak pasti yang macam mana Cik Hidayah buat apa, EIA ke ataupun macam mana? Cik Hidayah buat
Sorry?
apa? Cik Hidayah guna apa untuk reporting, untuk dari segi apa, EIA report ke ataupun apa sebenarnya bidang Cik Hidayah? Saya nak tahu lah.
Sekarang ni belum buat reporting lagi lah, cuma nak tahu kalau in real industry punya situation, application ANN tu dia macam ke arah yang mana. Sebab kalau yang saya tahulah, selalunya kalau benda-benda ni diorang akan guna untuk application like guna macam untuk artificial intelligence macam tu lah. Tapi saya tak tahu, saya just nak tahu sebagai Dr. Saiful lah yang berada di dalam industri macam tu.
Alright, saya akan cerita sikit. Saya pernah ada pengalaman. Sorry Dr. Ahmad, I will explain in bahasa first. Saya pernah ada pengalaman dalam consultancy bersama, tadi ada Dr. Azman tadi. So ada satu syarikat, dia perlukan prediction model untuk air quality, untuk Malaysia punya air quality. Jadi saya dengan Dr. Azman ada berbincang. Dr. Azman Aziz adalah tok guru saya lah masa saya buat PhD lah. So kami konsult satu syarikat tu dengan menggunakan ANN yang kita belajar tadi. Let's come up with the formulation dan kami jual formulation tu pada syarikat tu. Syarikat tu pun present kepada DOE, Department of Environment, dan benda tu yang sekarang ni yang keluar daripada website tu adalah salah satunya hasil tangan kami lah, prediction for air quality.
I see, okay.
So itu yang industri yang nak lah. Kadang-kadang dia nak tahu macam mana kita nak buat prediction tu, apa yang kita boleh hasilkan dengan prediction tu. So sebelum ni dia ada masalah dengan prediction, so dia datang kepada kami bincang macam mana nak dapat hasilkan prediction equality yang baik. So kami present, ini cara dia dapat yang macam yang saya tunjukkan tadi, yang formulation, yang coding tu. So dia gunakan coding tu, dia masukkan dalam sistem, dan sistem tu yang berjalan lah dengan DOE sekarang ni lah. Itu salah satu yang pengalaman saya lah dengan industri yang betul-betul. Kalau untuk reporting, kalau macam Cik Daya dalam bidang environment, perlukan environmental impact assessment punya report ataupun EMP, biasanya dia tak perlu terlalu detail on statistik, tapi perlu untuk pembuktian. Macam tak silap saya, Dr. Syirwan pernah berpengalaman dalam di semasa beliau di Jabatan Kimia dulu. Itu maksudnya, itulah kita punya, macam mana kita nak tentukan situasi kita punya analisis statistik ni dalam yang tertentu lah, situasi tertentu. Kalau perlu report yang biasa, pada pandangan saya boleh masukkan, tapi tak perlu detail, sebab report ni takut orang tak faham. Kan, so kita more kepada layman lah. Kita boleh masukkan elemen tu, tapi just ni. Tapi kalau orang perlu kita justify kenapa ini berlaku, baru kita keluarkan ini kenapa, sebab ini sekian dalam statistiknya, p-value ni macam ni, memang significant or not significant. That's why they need us as a researcher lah, not as mathematician, tapi as a researcher. Okay, this proof by statistic. Itu pandangan peribadi saya lah.
Okay. Alright, faham. Okay, thank you Dr. Saiful.
Okay, ada apa persoalan? Any question? So saya dah habis dengan exercise dan contoh. Kalau ada yang nak share, boleh share, sebab kita ada lagi setengah jam kat sini. Kita boleh sama-sama buat lah. If you guys have a data, we can discuss together. Alright.
Dr. Saiful,
Ya,
saya tengok yang JMP ni,
ya, ya, ya.
yang kita install ni apa JMP 19 ni.
Ya, 19. Saya pun habis JMP 13.
Sekejap boleh saya share kejap.
Silakan.
Sekejap ya. Nampak tak yang ni? Nampak dah? Sekejap, saya pun kena tekan ni. Kalau tak saya annoy. Perasan tak sekarang ni Dr. Saiful yang tadi yang kita buat hidden note tu, kita tulis tu 3 je kan, 1, 2, 3 kan. Sekarang ni dekat this part ni dia ada 3 jenis function dah sekarang. So yang tadi kita buat ialah tangent H tu yang ni kita letak. Sekarang ni dengan yang 19 ni dia ada linear dan juga Gaussian. Maksudnya kalau kita nak buat MLR pun kita boleh check kat sini. Taklah ni just update je lah. Maksud dia kita boleh buat MLR direct dengan Excel step tu, tapi sebenarnya kalau kita rasa kita malas nak pakai dua software, boleh pakai tangent dulu untuk berapa hidden node, run, and then kita buat sekali lagi guna linear pula, letaklah satu hidden nodes ke run. Lepas tu boleh buat comparison secara terus.
Lagi bagus lah. Saya kena beli yang baru ni.
Taklah, just nak beritahu lah sebab tu yang saya just nak share lah kan, takut nanti maksudnya kalau ada participant lepas ni nak belajar ANM ni, kalau dapat yang ni mungkin kita boleh simplifykan lagi ke, tentulah.
Dah ada robust fit.
Itulah saya tak tahulah, mungkin next time dia akan tambah function lain kan.
Betul. Sebab benda ni, so kita tak perlu banyak software lah sebenarnya. Tapi setakat ni saya memang gunakan banyak guna SSTAT. Untuk prediction, saya suka gunakan JMP lah. Sebab satu, dia user friendly berbanding R software, berbanding yang lain-lain lah. Tu pendapat saya lah. Saya lagi suka sebab dia senang nak guna. Walaupun dia keluar coding pun, kita boleh copy paste balik, dia akan generate semua apa yang kita nak lah. Tapi ini adalah first time saya tengok ada linear quotient. Wow, menarik. So boleh
itulah saya.
Test. Okay, ni yang data rainfall yang kita tengok tadi. Okay, saya cuba untuk kelaskan station menggunakan data rainfall. Ni saya pun cuba jaya je ni. Saya pun tak pasti dapat ke tak. Elok lah. Okay, untuk ni kita masukkan dulu data station. Okay, kat sini hierarchical kita guna what method. Sebab kalau dalam ASS stat pun biasa kita guna what method. Okay. Dapat lah. Dapat ke Syubai? Nampak tak? Tapi macam banyak sangat lah. Okay. Saya rasa saya silap kat sini. Dia kelaskan hari kat sini. Alright. Mula saya buka sikit. Saya dah cerita panjang tengok mana senyap tu dia keluar. Alright, sorry Okay, saya sambung tadi. Satu soalan tersyuruan tadi. Okay. Saya pun tak familiar sangat tentang keluarga KCMP.
Doktor boleh share screen?
Gangguan halus mengganggu. Okay. Nampak? Nampak ke?
Okay.
Saya terputus. Alright, okay. Alright. saya gunakan contoh data, menggunakan data rainfall. Mula kita gunakan sendiri. Okay, sekarang ni, kalau yang tuan-tuan, you guys dah biasa guna clustering dalam SSStat. So, ini pun ada juga function clustering. Okay, pergi ke analyze and then clustering. So kat sini kita ada beberapa teknik clustering lah. Hierarchical, k-means, normal mixture, class, cluster variable. So biasanya yang biasa dari cluster lah, menggunakan one method lah. Alright. So penyusunan data juga main peranan. Macam di JLP ni, kita perlu susun data macam ni. Kalau susun data station dekat atas pada kolom, so dia akan kelaskan hari. Kalau kita susun hari dekat sebagai kolom, dia akan kelaskan station. Faham tak? Okey, dia berbeza.
Dia macam terbalik, macam
Yes.
Excel stat sikit.
Ya betul. Kalau Excel stat, kolom kita ada station. Boleh je sebagai row kena edit Excel stat lah. Tapi jadi kalau kita nak kelaskan station, kita perlu kelaskan kita punya hari sebagai kolom dan station sebagai row. So kita kelaskan mengikut row. Masukkan kita punya kelas hari pertama sampai hari 294 dalam Y column. Alright. So dekat sini option kita ada beberapa kan. Ke normal mixture ke, so kita gunakan what method lah. Kita guna central boleh, sini boleh. So you guys boleh explore macam mana nak gunakan yang baik, tapi yang biasa saya gunakan adalah what. Program kita kalau dalam apa nama, dah buat kita compare dengan SSStat pun sama, kita dapat 3 kelas. Okey, kelas yang ni, yang 8, 11, 10, 11 ni adalah yang masa saya buat tu adalah kelas yang high lah, rainfall dia banyak taburan hujan. Kelas sederhana dan kelas 1 adalah yang rendah. Okey, apa lagi yang kita boleh tengok? Benda lah. Sini dia dah colourkan siap-siap kat sini. Kelas tamu. So sini ditentukan kita ada kalau tak silap saya dalam SSStat kita ada apa nama Euclidean distance, tak silap saya kan. Okey, kat sini kita dapat tentukan kita ada 2 kelas. Kelas 1 dan kelas 2 kat sini. So dia membezakan dengan warna lah kat sini. Alright, hijau dan merah kan. Alright, so kita ada juga banyak lah kita boleh bayar kita cuma ni bukanlah. Okay, ni kita tentukan sendiri. Kalau kita tukar awal dapat kelas saja. Macam tu lah. Alright, so sini pun kita ada descript. Sebenarnya kalau dalam penulisan cara kita dah boleh menulis lah. So yang pasti tahu apa yang kita perlu buat, tahu apa tujuan yang kita buat. Right? Semua kalau you guys tengok dalam SS pun macam ada 3 kelas. Boleh lah ada kelainan sikit dalam penulisan.
Okay, thank you Dr. Saiful. So To other participants, any question before we end? I think our session we have another 10 minutes.
Saya ada lagi question.
Yes, silakan.
Dr. Saiful, yang for MLR tu kan, using analysis tool pack tu, kita tak boleh buat MLR ke? Sebab saya ada try buat tapi tak boleh. Ke yang untuk analysis tool pack hanya untuk single linear regression?
Okay. Menarik. Okay, kita boleh try tengok Sekejap, saya cuba buat balik exercise. Kalau tak silap saya macam regression tu single regression, tapi mungkin kita boleh cuba. Saya cuba saya cuba buat dulu sebelum saya share, tapi kita buat sama-sama lah. Saya share screen saya.
Lepas tu saya ada lagi satu soalan. Okay, kalau dekat dalam industri, apa yang saya nampak lah sepanjang saya attend kelas statistik analysis yang from industry lah, kebanyakannya memang tak buat normality test ke macam mana? Sebab kalau ikutkan experience saya masa saya belajar dulu, saya akan buat normality test dululah untuk tentukan data tu parametrik atau non-parametrik, ataupun nama lain dia linear ataupun non-linear. So bagi saya lah, kalau kita dah tahu data kita tu non-linear, kenapa kita nak guna like linear punya macam tu lah. So kalau dalam case industri memang tak buat normality test ataupun macam mana?
Okay. Untuk soalan tu okay. Baik, saya menjawab soalan pertama saya dapat buat je.
Okay, sure.
Guna data analysis. So untuk yang regression multiple regression, saya guna regression yang 4 Okay. So why input gunakan WPI and then my X yang semua lah. So bila saya tekan, saya klik okay. Line fit plot, okay. Right. Dapat je. Tak ada masalah. Masih dapat sama A2 0.96. So ini dia akan bagi line fit plot bagi ke semua regression bagi setiap variable lah. Okay. So A2 ni adalah meliputi Allah Akbar. Minta maaf, terputus lagi. Okay. Saya dah kembali ke?
Ya, sudah.
Alhamdulillah. Okay. Menjawab persoalan tadi, Cik Daya. Okay. Tak ada masalah, boleh buat je regression menggunakan data analysis impact.
Okay, saya dapat. Saya rasa saya yang dapat tu sebab macam Dr. saya pun bawah dengan MLR, dia tak boleh buat kalau dia ada classification group macam yang exercise rainfall tu kan. So yang tu memang tak boleh buat. Okay.
Ya betul. Alright.
So yang ni saya dapat lah. Okay. Thank you.
So maksudnya kalau kalau ada non-numerical punya data, memang dia tak dapat baca lah. Sebab dia tak ada kelas dia, maksudnya dia tak dapat kira kalau kita ada macam bukan nombor tu dia punya kelemahan lah kalau guna MLR ni. Okey, untuk menjawab soalan yang kedua tu, soalan yang kedua pasal normality Okey, dalam statistik sebenarnya sebelum kita melakukan analisis, ini advanced analysis ni kita perlu tahu sifat data kita. Sifat data ni maksudnya apa kita, skewness kita, kurtosis kita, data kita perlu tahu data kita normal atau tak normal. Okey, so far memang kebanyakannya kita perlu ada transform data kita pada normal. Itu dari segi matematiknya macam tu. Okey, tapi selama saya experience dalam bidang environment, memang data alam sekitar hampir mustahil untuk normal lah sebenarnya, sebab dia ada tinggi, ada rendah, dia fluctuate every time. Apa-apa jenis contohnya, kecuali lah kalau data yang memang constant, dia akan tak ada perbezaan yang kejap naik, kejap rendah, tu boleh kita jadi normal lah. Tapi biasanya data alam sekitar memang susah untuk normal. Okay, kalau saya salah, kalau betulkan saya ni. Okay, tapi dalam cerita Cik Dayah ni, sebenarnya kalau dalam untuk dapatkan dapatan yang baik, memang kita perlu normalkan data lah. Macam data alam sekitar, kalau kita normalkan data tu, bila kita nak baca balik, kita tak dapat trace. Okey, sebenarnya mana perubahan yang kita ada kat sini dan kat mana yang kita nak lah. So kita tak dapat nak explain balik dengan benda tu. Jadi sepanjang saya berguru dan berjumpa dengan mana-mana researcher dalam data alam sekitar, cerita dalam konteks data alam sekitar, memang kita gunakan data yang sama, yang raw, cuma kita clean dan kita treat data tu yang mana yang ada abnormalities, yang mana ada missing, yang mana ada outliers, ataupun yang maximum outliers, ataupun yang terlalu extreme outliers, kita eliminate semua possibility tu, baru kita jalankan kita punya analisis lah. Dia ada, kalau tak silap saya ada reference daripada jurnal luar negara yang pasal data normal tak normal ni. Kecuali lah kalau kita gunakan data social science, yes, kita perlu data yang normal lah. So data environment, memang so far pengalaman saya yang saya dah guna data air, data udara, data heavy metals, data macam-macam data dah saya dah guna, memang susah untuk kita dapat data yang normal. Kecuali kalau kita perlu normalkan pun, gunakan dalam access type kita ada function transform data, kita boleh normalkan data tu. Cuma yang kita akan sakit kepala, macam mana kita nak revert balik data normal tu kepada data tak normal untuk kita baca balik data tu. Itu yang problem yang kebanyakan researcher alam sekitar hadapi lah. Itu pendapat saya. Mungkin Dr. Syirwan ada penambahan ke untuk ni, sebab dia lebih pengalaman dengan data alam sekitar.
Tak apa, saya rasa itu pun dah menjawab dah sebenarnya.
Kan? Kan? Okey, terus pendapat dah saya rasa. So itulah Cik Dayah, kalau dalam untuk Cik Dayah sendiri, kalau data tu Cik Dayah ada raw data, pool of data yang raw. So make sure yang first you must clean your data first lah. Make sure you remove all the abnormalities, the extreme outliers, buang segala yang benda-benda yang bergepek-gepek. Kadang data ni dia boleh jadi dua masalah. Masalah pertama adalah main punya masalah manusia lah. Contohnya adalah handling sampel, mungkin ada contaminate atau spillage ataupun mesin rosak. So data itu akan jadi pelik lah. So itu yang kita nak buang benda tu kan. So kalau yang kedua adalah dari segi machine lah, ataupun machine rosak ke, rosak ke, ganggu kita punya data kita tu untuk dapat data yang baik. So bila data tu ada abnormal, mungkin pertama ada kemungkinan ada benda, contoh dalam konteks alam sekitar ada berlaku pencemaran, ataupun kalau ada sepanjang kita sampling tu ada satu point saja yang problem, yang seterusnya okey, maksudnya kita yang problem lah. Maksudnya cara kita sampling tak betul, ataupun cara kita analis buat lab analysis pun tak betul. Itulah yang kita nak mengelak lah. Jadi kalau nak kata normalkan data tu boleh, tak ada masalah, cuma macam mana kita nak cerita balik benda tu. Kita nak revert balik memang susah lah, nak revert kepada data asal tu. Itulah. Saya harap menjawab soalan tu lah tentang data normal.
Okey, menjawab.
Alhamdulillah, terima kasih.
Okey, terima kasih.
Ada soalan lain ke? Encik Syarul ada soalan ke? Dr. Azlin. Oh, Dr. Amal masih ada kat sini ke? Dr. Amal dah keluar?
Dr. Amal, she's here, but I'm not
she's
sure. Yeah.
Alright, okay. Saya explain pasal lain. Saya ingat dia dah tak ada kat sini. Minta maaf.
It's okay.
So okay, that's all lah saya rasa. Apa yang saya sampaikan ni saya cuba yang sebaiknya. I try my best to explain and to show you how the prediction model works and how you can apply to your data. And then if you guys have time to explore, I suggest you to explore the software and the prediction, because it's not just for your research, but you also can get boleh generate money lah. Maksudnya macam saya cerita tadi, from my experience, I sell my formula to the industry so they can use our data, our formula. So salah satu cabang lah. Itu yang kemudian membantu dalam penulisan kita jugalah. So macam just like I explained yesterday, if we have problem with our data, just like missing data or data so salah key data ke, tapi kita nak juga guna, tak nak ada logo data kita, mungkin kita boleh gunakan kaedah prediction lah untuk kita membantu dalam missing data tu. Yang kedua, kita yang seterusnya, we can confirm our classification. Macam saya tunjukkan dalam apa nama kita nak classify contoh kumpulan hujan tadi. So using ANN, we can confirm our class is at the right lah, maksudnya di tempat yang betul lah. Itu salah satu function yang kedua lah. If you guys nak belajar lebih banyak, lebih mendalam cara-cara chemometrik yang lebih tepat dan berkesan, saya suggest you guys masuk kelas Dr. Azman, sebab dengan belajar dengan multivariate analysis yang betul, so you guys boleh ikut flow dengan prediction model yang baik. Itu saya punya pendapat saya lah. Right. So kalau ada yang saya tertinggal ataupun saya tersilap, saya minta maaf banyak-banyak, ataupun ada gangguan internet, I'm very sorry. I hope you guys can learn something from this two-day course and can apply to your work after this. So that's all. Yeah. Back to Dr. Shirwan.
Okay, Alhamdulillah. Okay, thank you so much to our trainer, Dr. Saiful Samsudin, for your time and for your knowledge, sharing your knowledge. Okay, so I believe that we have come to our end of the session, and if all the participants, if one of you have any question, you can write to the Catalytics, or you can directly email to Dr. Saiful, and maybe Dr. Saiful can share your email to us so that the participant can email to you. And we have lots of we have more workshop to come. We have on March we have a session with Dr. Azman on the what? We have a training for the clustering, and we have the wait. Apa clustering
On March we have with Dr. Kausa, and on April we have with Dr. Azman. So if you have any problem or you like to know more about this training, you can subscribe to our YouTube and as well as our Twitter. Okay. So uh, for those who like to get certificate, okay, the catalytics will provide you the the certificate later, and then for those who have paid, we will provide you the receipt afterward lah. Okay, so I think that's all from the catalytics, and thank you again for to Dr. Saiful for delivering his workshop, his training for this 2 days workshop. And then hope to see you again in the next session. Okay, so apology from us if we're having problem related to all this managing of this workshop lah. Okay, again, Assalamualaikum warahmatullahi wabarakatuh. And if you have any problem, please just send our WhatsApp to our group, or you can send an email to us. Again, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you guys. InsyaAllah.
Waalaikumsalam.
See you again.
Thank you, Teacher Wan.
Okay, thank you.